Example 5 for 3.3, and I'm not quite sure if this is in the latest version of the notes. So if it's not, please do write it down on a piece of paper because this comes up in the assignment. So it is something I want to address right away. And it's basically going in the opposite direction that we've been doing in 3.3. Most of 3.3 is focused on completing the square, which is converting from standard form into vertex form. Example 5 is going the other direction to convert vertex form into standard form. And I always like, showing a little bit of a flow chart to talk about this because it is really important that if we want to go from standard form into vertex form, we have to complete the square. And that's really what most of 3.3 has been about. So complete the square. But if I want to go into vertex form to standard form, for whatever reason that is, it's actually much simpler to go from vertex form to standard form. All we have to do is expand, which is to say we're going to multiply the squared expression by itself and go from there. And I'd like to show that all that really means for this particular question is I'm going to rewrite this as y equals -2 times x minus 3 squared is x minus 3 times x minus 3. And then after all of that, I can add 8. Now, it depends on what you're comfortable with. I like doing the binomials first. So x times x is x squared, x times -3 is -3x. -3 times x is -3x again, and -3 times -3 is +9. And then the 8 is still lurking at the back. But it's really, really important that we have to distribute that -2 onto each and every term. So I'm now going to have that y is equal to -2x squared plus 6x plus 6x minus 18, and then plus 8. And now I'm going to collect my like terms. So y is equal to -2x squared plus 12x minus 10. And this should have the same value for every single x as the original version up here. Now, I would recommend bare minimum, you should check the y-intercept because the y-intercept is pretty easy from standard form, right? This tells me that my y-intercept is at 0, -10. It's the constant term. So if we've done this correctly, if I take the original equation given, -2 times x minus 3 squared plus 8, I should be able to get the same y-intercept. So y would be equal to -2 times 0 minus 3 squared plus 8. That's y is equal to -2 times -3 squared plus 8. This is y is equal to -2 times +9, right? A negative number squared is positive, plus 8. I get that y is -18 plus 8, and I get that y is -10. So we get the same y-intercept with both functions, which I agree is kind of the bare minimum verification you should do to make sure that you've done these questions correctly. If you want to do that in more detail, you should graph your standard form, this guy right here, graph your vertex form, and make sure that the graphs are identical. That's a really solid technological way of verifying as well. All right, I'm going to put the full assignment up for 3.2. The review's up there as well, but please ensure you're checking Google Classroom for any kind of modification.